relationship. Before we get into that, let's do a little bit of a review with this problem. I want us to state what law we are using and what will happen to the final volume if pressure is doubled. So we have a sample of gas, 1 liter sample of gas, and a P1 with the final volume we are looking for, V2, and it's telling us if pressure is doubled. So P2 is equal to 2 times P1. So now let's set up our variables. P1, V1, P2, V2. What law is this? This is Boyle's law. Okay, we have 1 kilopascal is equal to, volume is equal to 1 liter. Pressure, what happened to pressure? It was doubled, so times 2. So that gives me 2 kilopascals. And we are looking for volume. Did pressure increase or decrease? Increase. So what's going to happen to our volume? Decrease. Let's test that out. We are looking for V2. So that's going to be equal to P1 V1 over P2. Plug in those numbers. 1 kilopascal times by 1 liter divided by 2 kilopascals. Kilopascal cancels out with each other, and I'm left with 0.5 liters. Oh, sig digs. How many do we need? 3. Let's 0.500 liters. This is a leading zero. It does not count. The leading zero doesn't affect sig digs. Okay, using the following information, complete the graph and the table. A container holds 5 liters of gas at a pressure of 200 kilopascals. This will be defined by the first point on our table, right here. The pressure is increased in the container. Let's make a prediction first. What will happen to volume as pressure increases? Okay, so we predict as a class that it's going to decrease. Let's test out our theory. So your assignment today is going to be to create graphs. I'm going to go through the first graph with you, and then I'll give you some pointers on the next 2 graphs, but they will be up to you to graph. So here, we are saying that the pressure is increasing. We have given you select points to try to calculate your pressure at. I'm going to consider my first point as P1, V1. I'm going to consider my next point, P2, V2. So we're going to look for V2. I'm always going to take my given point as P1, V1. Okay? So we will first calculate this one, and then we will use P1, and we will use this as P2 to calculate the next volume. So using Boyle's law, P1 V1 is equal to P2 V2. V2 is equal to P1 V1 over P2. Plug in those numbers. 200 kilopascals multiplied by 5 liters divided by this, our P1, or sorry, our P2, 320 kilopascals. Kilopascals cancel out, and you will get an answer in liters. Okay, take a moment, and then tell me what you get. So, when you calculate this out, what do you guys get? Give me 1 sig dig. Oh, sorry, 2 sig digs. 3.1. When we are graphing, it makes sense to have 1 decimal point only, because if you get too accurate with your decimal points, it's hard to graph. So we're just going to do 1 decimal point when we are doing. So 3.1 liters. Okay, now same thing. We are still going to consider this as our P1, but we are now going to change our P2. So the formula stays V2, P1, V1, P2, 200 kilopascals times by 5 liters, divided by, now this will be our P2, 450 kPa. Okay, calculate that out. That'll give us this value here. Yes. Yep. Okay, again, we only want to round to 1 decimal place because it makes it easier for us to graph. This gives me 2.2 liters. So I will put that there. Last one, I want you to calculate on our own, and then we will draw this graph. Okay, if you continue to do the same step, you will get 1.8 here. Okay? Now, let's go over some graphing 101. Which variable goes on the x-axis? Manipulated, responding, or manipulated. Sorry, I should have been. Okay, your manipulated variable is always on the x-axis. The reason why pressure is our manipulated variable is because it is the values that we physically changed. Okay. Also, this represents the x column. Okay. So the values that we are physically changing will always be in the first column of the table, in the x column of the table. On the y-axis, what type of variable do I have? Manipulated, responding. Okay, responding. Your responding variable will always be in the y column or the y-axis of the graph. Okay, because we calculated these values, they will be our responding variable. When you are plotting on a graph, you are going to read the points across. This point here is your x, this point here is your y. So I find my x, 200, I find my y, 5, I cross-reference those to make my first point. Okay, let's do the second one. 320, and I'm going to say is around here. And 3.1 is going to be slightly above that 3 line, so it's going to be about there. Okay, take a moment, plot those points up on your own, and then we'll come back. Okay, so once you plot the points, this is what you will have. So remember a couple days ago when we actually learned about Boyle's law, pressure and volume, I was drawing a curve like this. This represents an exponential relationship, or a 1/over relationship. You'll notice that we get the same line when we actually physically take data and graph it. Let's talk about our responding, manipulated, and controlled variables. As mentioned to you, we have the following 4 variables that we will be using in this unit. Which one did we say was our manipulated? Pressure. Which one is responding? Volume. What is controlled? Moles and temperature. Good. What gas law does this represent? Boyle's law. Read the graph to estimate the following values. So at around 430, this is where you draw that nice line on your graph. You draw that nice curve. At 430, let's go back to our graph. Where's my graph? Scroll up. Okay, there it is. So it says at a pressure of 430, approximately, what is my volume? So I would say about 430 is right there. So I'm going to read up and then read across. What would we say? About 2.5. Okay? So at about 400, my volume is about 2.5 liters. Same thing. It's saying if volume is 4.5 liters, then what is pressure? So we go up. This time, we are looking at our 4.5, which is about here. So we read across. And then we read down. About how much? 220-ish, okay? About 220 kilopascals. So now I'm going to explain what happens. You will be doing the following two graphs on your own. The first graph you're going to do on your own, it is the same as the example we've done. So you will have to read the problem. You will use the points on the table. Sorry, first thing I do is RTF. That's always step one. From there, once you have read your problem, you are going to make a prediction. What will happen to volume as temperature increases? Okay? Then you will use your table to calculate your V2. Then you will graph the relationship. Your graph needs a title, axes labels, with an appropriate scale, okay, number scale, axes labels with units. So you're going to use the graph that I had previous as an example. Okay, there's graph number one. Then same thing, you will identify your manipulated, responding, controlled variables, label the axes on each graph, and what gas law does this represent? And then you will go forward and read the graph as well and estimate the following values. For this last one, the table is kind of blank for you. So same thing, first step, RTFQ, read the fantastic question. And then you're going to make a prediction. What will happen to volume as temperature increases? No, this should say what should happen to temperature as pressure increases. As pressure decreases. All right, we're going to just change that whole statement. So we're going to say what will happen to temperature as pressure decreases. Oh, yours is right? Mine's wrong? Okay, listen. So now, for this one, you will be physically manipulating the variable on your own. So what is it saying is happening to pressure? Decreases. So you need to pick numbers that show that the pressure is decreasing. So if it's decreasing, you pick a number under 185. So I would say maybe 175. You will be physically manipulating pressure on your own and seeing how temperature responds. I want you to choose different numbers from the people sitting beside you, and then I want you to see if your graphs look the same. Okay? That's all. That's the lesson for today. So you're going to work independently with this. Okay? Let me know if you have any questions. Okay, one last thing. When you are drawing the graph, you will have 4 points on it. Okay, listen. So I'm drawing this as a disclaimer. Do not take these points to heart. So let's say I have a point here, a point here, a point here, and that's it. When you are drawing your line of best fit, I want you to extrapolate your line. So you're going to go like this. You're going to extrapolate it beyond your data. So when I say, like, let's say this is 10, 20, 30, 40, 10, 20, 30, 40, and I ask you, what is, let's say that this is temperature, let's say this is pressure, what is the pressure at 40 kilopascals? Sorry, at 40 Kelvin. So I read up to 40. on the line of best fit, I come over and I would say it's approximately 40 as well. So you will have to extrapolate your line past the data so that you can estimate those values. Does that make sense? Okay.